Shirts now ready to ship for $25. Get yours now at scaleyourcode.com/shirt while supplies last. In this episode, we talk about building APIs for large volume and what to do when things go wrong. How do you track errors in development, and how do you know when your users run into errors? Do you even have an error tracking strategy? Mine was terrible, but I found a solution that I really like. Rollbar is an incredible product, and I'm not just saying that because they're sponsoring the show. I'm actually using Rollbar at Scale Your Code. I'll tell you more about that later in this episode, but go to try.rollbar.com/SYC and set it up with your app. It's really easy. It took me 5 minutes, and it works with any language and any tool you need. Try.rollbar.com/SYC. Hey fellow developers, my name is Christoph, and you're watching the Scale Your Code show. This is a show where we talk about things like web performance, scalability, and really just how or why things work the way they do. Now today's guest is Daniel Kador. He's the CTO of a company called Keen IO. Keen is or offers a set of analytics APIs that really help you collect, analyze, and share data. Dan, welcome to the show.
Thanks for having me.
Before we get started in talking about Keen IO, can you tell us a little bit more about your background, what you've worked on, where you come from, that sort of thing?
Sure, yeah. So I've been working on Keen for about 4 years now, which is a little crazy. It's been a bit. Before that, I was at Salesforce. So I spent about 5.5 years at Salesforce as an engineer on their developer platform team, where specifically I helped them build APIs. So I did that for a while. By the time I left, I was basically like a lead or an architect on that team. And before that, I was in school where I worked at a bunch of different internships, studied computer science, but that's the short version.
Cool. So 4 years of Keen, and you guys started or went through the Techstars program, is that right?
That's right.
Can you give, I gave a brief explanation of what Keen sort of does. Can you give us a little bit more information on what it really does and how it can help developers?
Yeah, so the short version you gave is totally right. What we do is we make it really easy for any software developer to collect data from basically anything connected to the internet. So that could be a desktop browser, it could be a mobile app, it could be a backend server, it could be a smartwatch. Mm-hmm. Once that data is collected, it lives on our servers. We handle the hard problems of storing and scaling that data, and then we make it very easy to ask questions of it. So you can use our API to send questions. We'll crunch those numbers, we'll give the results back, and then we finally make it really easy to share the results of that analysis, either through charts or dashboards or through other API integrations.
Okay, so say I have some kind of web application, for example, and I want to send a number of purchases for specific products. I can just, like if I'm using PHP or Ruby or whatever, you load it as a dependency, add a few lines of code, send that information to your API, which is then processed, however you process it, which we're going to expand on in just a little bit. And then you store that information, and at pretty much any point in time, I can go back and say, hey, can you send me the average of sales for this product, or the maximum, the minimum, that sort of thing. That's pretty much in a nutshell how it works.
Yeah, that's exactly right. And we have lots of different use cases. One of the main ones is for folks who want to deliver analytics to their customers. So people use us a lot to power the analytics that they serve to their customers. But we have lots of use cases.
Some of this is really critical. I mean, some of the businesses actually depend quite a bit on this service then.
Yep. Yeah. Many of our customers were critical path for their app. Many of our customers generate revenue with us, which is really cool.
Awesome. Let's break this down a little bit more now that we have the nutshell. Can you describe sort of like step by step where I'm sending the data, what happens to that data, how that data stored, where is it stored? Can you give us some more information on that?
Yeah, of course. So, excuse me. So, we'll start from the beginning. So we were hosted entirely in SoftLayer today. We made that decision back in 2012. We needed more IOPS than AWS could give us, and we'll talk about why that is in a minute. But starting from sort of the front end, we use Nginx as a load balancer. Traffic comes through that both for our website and API. Web servers, Python built on top of Flask. API is Python built on top of Tornado. And then there's a couple different services and layers underneath. The main ones are we have, we'll just talk about the data processing tier because that's like really where most of the heavy lifting happens. So we have Kafka, which handles our event queuing. We have Storm, which handles the distributed computing of for both writing data, persisting data to disk, and querying data, orchestrating our queries. And finally, we have Cassandra, which is our persistence layer.
So let's see, Nginx, Kafka, Storm, Cassandra, Python, Tornado. Why Python?
The shortest answer is I was coming from Java and wanted to do something different.
So there's not some kind of really drawn out. You just wanted to give it a shot, and
No,
it
I'm
happened.
a relatively pragmatic programmer, so I think you could build the API tier in many languages. Python has worked okay. There have been challenges with Tornado and a bunch of good things with it too. So if I were doing it again today, would I choose something else potentially? But works pretty well.
Cool. Same thing with Cassandra. Was there didn't you switch from MongoDB? You were on MongoDB originally, and then you ended up switching.
Yeah.
Did you just switch? Did you just decide to use MongoDB just to give it a shot, or had you had experience with it at Salesforce? What was that process like?
Yeah, so one of my co-founders built something that looked a little bit like Keen at a previous startup using Python and Mongo. So that's where that came from. We also picked it because it gave us very quick iteration speed. It was easy to get started, easy to get moving, easy to make changes. We knew from the very beginning that it wasn't going to be the thing we used to scale the company. But when we started the company, the risk was not, does the tech scale? The risk was, can we deliver a product that people are going to be interested in? And once we crossed that bar and saw that, okay, this is a product that's resonating with the community and people are enjoying it, and we think there's a big business opportunity here, that was when we knew we needed to do the investment into scale.
Can you share some of the stats of how many requests per second you get, how much data you're processing, that sort of thing?
Yeah, not all of these are. Some of these things aren't really public, so I play them a little close to the chest. But we're doing thousands of requests a second. The more important thing I think is how much data we process. So everybody talks about how much data they collect, and there's interesting numbers there. But I think processing the data is the really interesting stuff. So we're crunching trillions of events per day, and when I say event, I mean like a rich JSON document that involves potentially tens or hundreds of properties. So it's a lot of data that we're moving around in our between our servers.
So did you get to a point where MongoDB just couldn't really scale anymore, and that's when you switched it, or did you anticipate it not being able to scale anymore? When was that? When did that happen, really?
I mean, it was a little bit of both, right?
Yeah.
We knew it wasn't going to scale. It caused some problems, or it wasn't serving some of our biggest customers in the way that we needed it to. For most of our customers, it was fine, and we built the new system in anticipation of making sure that most of our customers would not be okay on Mongo.
What does Cassandra offer that Mongo didn't?
It's a distributed system from the core, right? So it, unlike Mongo, which it does have sharding, but even that is challenging. Cassandra is a distributed system from the start. It's columnar, which maps well to analyzing specific properties within a JSON document. But it's really about being able to scale by adding more nodes and having that work in a realistic way.
And the nature of the analytics and business itself, is that why you didn't decide to go with something like MySQL, for example, that's really battle tested and hardened?
Well, it's just every customer we talk to has something like a MySQL. They've tried to create their events table, and if they achieve any sort of reasonable amount of success, that events table breaks their database. That's just
Mm-hmm.
how it works. The
Mm-hmm.
scale of data is much too big for a single SQL node, whether it's MySQL or Postgres.
Mm-hmm. When it comes to Cassandra, out of the box, did you have to tweak any specific settings for your application itself? Was there anything that just didn't really fit well, or a few tweaks that helped it perform better that you can think of?
Yeah, I mean, we've had to do a lot of work to scale and to tweak in the right way. So, I mean, Cassandra is based on the JVM, so there's the basic JVM stuff of heap size tuning and GC tuning, um, and there's not really any magic numbers there that work perfectly. You have to figure out what works for your workload. Um, I think the most interesting thing we did with Cassandra was figuring out how to store JSON JSON documents in a columnar way. So we've done some really interesting things at the data model layer of basically transforming groups of events into columns and then storing those columns in a more compressed format. It makes it really easy to do the kinds of bulk aggregations that we do.
Mm-hmm.
So it's really all about the most important thing has been the data model.
Seems like one of your engineers gave a talk on that, if I remember seeing correctly. I'll try to find that again and link it below the video. That was pretty interesting as well.
Cool. Yeah, that'd be great. That talk is definitely out there.
When it comes to this sort of data where I'm querying for a certain set or a certain average or maximum summary or whatever, how much of that can you really cache? I mean, do you have a lot of repeated queries, or do they constantly change? What's the challenge there?
There's a ton of challenge there. So what we advertise to our customers and what we deliver is you can send us arbitrary data. We don't require you to send indexes or, schema beforehand. So you can send us arbitrary data. You can send an awful lot of it, and you don't have to predefine your queries. And so that's a pretty tough challenge.
Mm-hmm.
So there's no, at base case, there's no caching. Because we might get a query for something we've never seen before. That being said, there's a lot of caching that we can do in practice because many people, like say somebody's building a dashboard, those queries are being run over and over again. And so we do lots of different kinds of caching, whether that's like a recency caching of just saying if you've sent a query, you're probably going to send it again, so let's keep that result around for a little bit, 60 seconds or whatever. Then we do caching at the disk layer as well. So instead of having to pull data from Cassandra for certain kinds of queries or certain periods of time, we'll actually cache that in memcache local on the instance. And we also do, for our more enterprise or Keen Pro offering, we have what we call like query caching or dashboard caching. And where you'll be able to, what happens is you can predefine your queries that you want to happen quickly, and we'll make sure the data is loaded and fresh for you.
So when you're talking about customer dashboard and Keen Pro dashboard, you can actually build your own dashboard internally and just receive the data itself and then display charts or whatever it is with your own JavaScript libraries or whatever you're using. Or you can use Keen Pro that already has those charts and that type of information. Is that how it works?
Not quite. So
Okay.
all of our customers have access to all of our visualization tools. So you can sign up for free today and use our JavaScript SDK to send data and then build charts. Build charts and dashboards that are nice and attractive and modern looking. What Keen Pro gives you is a set of features on top that are pretty common for all of our most successful and largest customers. One of which is this idea of caching the dashboard. So if you're a free user, we're not going to try and pre-compute or cache results for you. But for some of our Keen Pro customers, that's really important. Folks who are building analytics for their customers, they often want those dashboards to load, sub-second or sub-2 second or whatever. And the reality is when you're crunching billions of data points, you need to do some sort of pre-aggregation or caching. So we do that for our customers.
So how do you know what you want to pre-aggregate?
The customer tells us.
Okay, so they go to you and they say, "Hey, this is what we want." I gotcha.
Yep. So
okay.
they send us through the API. They say like, here's a query that I want, or here are a set of queries that I want.
Okay, I see.
Mhm.
You said that you guys use Kafka for queues. Can you give us some use case examples of how it's really used?
Yeah, I mean, it's a core piece of the stack. It's the layer that all incoming data is persisted to. So when you send us an event, we say we don't say it's safe until it's persisted to Kafka, and then Storm listens to the Kafka queues or reaps the Kafka queues, and that's the thing responsible for persisting data into Cassandra. At which point
I see.
the data is available for querying.
Okay, so from Kafka to Storm, you do some
Yep,
processing with Storm, and then you
that's
put
right.
it in Cassandra. What kind
Yeah.
of processing do you do with Storm?
So we basically do so all events from all customers go into the same queue. And
Okay,
so Storm is responsible for sort of collating them and collecting them into the appropriate, in SQL you'd call tables, we call collections. Um, so to make sure we're keeping data secure and not giving anybody access to things that they shouldn't have. So we're quite good at that. We also do a bunch of data processing related to what we call our add-ons. So you can turn things like IP addresses into geo information, parse user agent strings, um, do some URL parsing. There's a few of these.
mm-hmm.
So we do a bunch of that. Um, and then there's all the storage optimization we do. So all the compression and serialization happens there.
So Storm is a stream processing service.
Yep.
Why did you decide to go with Storm?
Because we needed a stream processing service, and
Mm-hmm.
when we
Is that
started
really
build,
the best that you can find out there?
well, it was. I
Yeah.
think nowadays there's there's some pretty healthy tech being built both in Storm and in things like Spark.
Mm-hmm.
So um, there's a lot of cool things out there. But when we started, Storm was kind of the de facto standard, so we
Mm-hmm.
built around that.
I've done very very little with Spark itself, just a few small projects just to see how it works. And since
Mm-hmm.
we're moving towards that kind of technology nowadays, when I was doing the projects with it, I would use something like D3 to visualize the results. What kind
Mm-hmm.
of technologies are you using to visualize this data?
Yep. So our JavaScript SDK is built on a couple of things. So when we started, we built on Google Charts. So it's a wrapper around Google Charts and does a lot of things it gives you the visualization's a lot more sort of easy and simpler than using Google Charts directly. These days we've got wrappers for D3 as well.
Okay.
So um, that's definitely sort of the direction things are going.
Yeah, it's an incredibly powerful tool. It really is. Some of the
Yeah.
charts they've come out with, the visualization, you're taking millions and millions of data and just displaying these beautiful charts that you can
Yep.
look at it and you can just make a decision just like that. There
Yep.
was one I think the New York Times created this one where you had a map of New York and it was showing the crime rate back in 2012 and then again in 2014 or something like that, and you could clearly see some of the areas that have the highest crimes, and depending on the year itself. Imagine looking through millions of sets of data and trying to figure that out. That would take you months, if not years. With something like D3, you can just literally just look at it and figure it out in a
Yep.
second like that. It's incredible. It really
Yep.
is.
Pretty powerful.
So when you're looking at some companies that have very powerful tools that need documentation for their APIs, I've personally almost banged my head against the wall sometimes, literally, just in frustration at the
Yep.
lack of documentation or the lack of information that they provide. You guys rely extremely heavily on your API, which needs to be well documented. What kind of advice could you give to other companies on how to build better documentation?
Yeah, it's a good question. It's super important for companies like ours. Anytime one of your main target audiences is developers, and you got to have good docs. So, I mean, there are a couple things that are important, right? So one is just straight up iteration speed. How quickly can you make changes? Two is who can make changes. So the more that you can get your community involved, the better. Um, you know, so that could mean having the whole thing be hosted in an open source GitHub repo. It could mean having the ability to send in comments and say like, hey, I think there's a mistake here. Because one of the things you just really don't want to do is have your docs be wrong and not be hearing about it from your users,
Yeah.
because that's poisonous. Three is they need to be elegant, right? Like they need to actually work. You need to be able to search them. They need to hopefully have good Google SEO, so you can actually find stuff. Many people just find stuff by Googling,
Yeah.
Keen plus whatever piece of our API they're interested in. Um, so today we have like a single page, kind of a single page app for our docs, which makes some of the SEO stuff tricky. So there's some interesting techniques we had to deal with there. But at the end of the day, it doesn't feel like rocket science to me. It's spend time. You have to invest
Yeah.
time in this, and you have to invest resources, and it's worth it.
Hmm. It's not necessarily a second thought. It should be something that you really truly care about. And so
That's right.
you've open sourced a lot of your tools. Is that for the same reason, to be able to get feedback from the community where they can say, hey, we really want more of this, we want
Hmm.
less of this, or we don't care about these things?
Yeah, I mean it's to build a community together.
Yeah.
We've got what I think is the largest open source analytics community out there, and we've done it. It helps us certainly as a business, but it's also because we want to help the community out. We wouldn't
Hmm.
exist without it, so we want to give back in the ways that make sense.
What are you using to create your documentation? It seems like I've seen the same style for a few different companies. Did you use something pre-existing, or is it?
So we're kind of using something mostly homegrown. I mean, it's built
Okay.
on the sort of a normal JavaScript tool chain around, grunts and
Yeah.
things like that. But the sort of style and everything is largely homegrown at this point.
Hmm. Okay, cool. So another challenge that I was trying to think about when doing this, the research for this interview, is you've got a lot of data. How
Yep.
do you store this data? How do you make sure that it's in secure location? How do you move it around? How do you like put resiliency on it? How does that work?
Right. So from a security perspective, we're hosted inside a SoftLayer, which is owned by IBM now. Um, so it's quite sort of secure from the get-go. Our networks are all isolated, so we're on completely private networks. Um, Everything's firewalled. All that stuff's managed automatically through Chef. So um,
Hmm.
and so from that access perspective, we're doing sort of all the right standard things. Um, from a how do we store it, like I mentioned before, this all eventually gets persisted to Cassandra. That's where data lives at rest. Um, we're using the right ways to authenticate against Cassandra, and making sure
Sure.
that even if people got access to the network, they'd have to have access to credentials to do anything with the data. Um, in terms of storage format, it's like I mentioned, it's columnar. So we're
Hmm.
basically taking collections of up to 5,000 events at a time and breaking them out into their properties, and then storing 5,000 properties at once in a single column. Um, and then that's how data lives at rest.
Hmm. Cool.
Yeah,
What about monitoring? What kind of tools are you using? How does that
yeah,
work?
yeah. It's incredibly important. Frankly, we probably spent more time building monitoring tools than in some ways the core product. Because you just gotta, I mean, you have to know if it's working, right? Like I said
Hmm.
before, we're a critical piece of many people's infrastructure, and we have to know when things are going wrong before our users do. Um, so, I mean, we're a big user of ourselves, as you might imagine. Um, so we do a lot of dog fooding there, but we want to make sure that we can know what's going on, even if our core systems are having problems. So
Yeah.
we use
Right.
other services as well. Probably the biggest one is Datadog. So we use Datadog as a sort of central aggregation point for most of our metrics. Um, Everything from front end load balancer stats all the way down to really core Cassandra, JVM, like JMX things. So we've got a bunch of dashboards there. That's where most of our alerting happens. It's all through PagerDuty. Um, and a lot of we just use sort of the standard ecosystem of tools to send data to Datadog, whether that's Datadog SDKs in some
Hmm.
cases, or some of the more normal like metrics forwarders that exist out there. Um, we had to build a bunch of custom stuff for Storm to monitor basically how Storm is doing, processing things from Kafka. Because I've talked about sort of the main path of events from hit the API, go to Kafka, and then go into Storm and Cassandra. But there's a bunch of other jobs we have that move data between Storm, Cassandra, and Kafka to do various things. So we have to monitor all those and make sure the jobs are keeping up and aren't restarting, and all that good stuff.
Mm-hmm. So guys, you heard it from Dan himself, the importance of just tracking errors and knowing when errors happen, or even trying to figure out what error is going to happen before users run into them. If you're looking for a reliable and easy solution to track your own errors and exceptions, I highly recommend Rollbar. Rollbar has already sponsored 7 episodes of the show because that's how helpful they've been to developers like you who listen to the show. It doesn't matter how big or small your app is, or what hosting provider you use, Rollbar only takes 5 minutes to integrate. Once integrated, Rollbar gives you real-time reports on errors your users run into. All of this gets reported in a clean dashboard where you can filter through local errors, development errors, or even production errors. Get a free account at try.rollbar.com/SYC. That's try.rollbar.com/SYC. You'll be really glad you did. What do you guys use for error tracking, by the way?
So for a long time, we had a homegrown thing that was mostly based on email, and then more recently, I've switched to a tool called Sentry. But they're super important. You got to pay attention.
So why did you switch? Why not just stick to your homegrown solution?
Because getting bombarded with emails in the middle of the night was pretty unpleasant. So we needed a better way.
It's kind of like trying to build your own data analytics system, isn't it?
Yeah.
You have to think of all the security, the volume, DDoS attacks, all that sort of thing. Same thing with error tracking. So make it super easy for you, and have a flexible service like Rollbar.
Yep.
So Dan, you've had some performance issues in the past. I know one of your first, if not the first outage, was back in 2013.
Yep.
That was a problem with a query that kept running, and Nginx was passing the request onto every single web app, is how I understood it.
Mm-hmm.
When running into these issues, how do you handle it? I mean, you're dealing with critical information for businesses, right? These businesses, like we mentioned, rely on your service working. How do you handle these failures?
Yeah, I mean, we take them seriously. They're, we're monitoring things 24/7 to make sure these kinds of things don't happen, but we're not perfect, and sometimes systems fail in really unexpected ways. In fact, they basically only fail in unexpected ways because we've taken account for all the ways that they might fail expectedly. So it's always a case where 3 or 4 things work in concert to really act in a way that is surprising. Mm-hmm. So in 2013, what you said is right. We had we were still running on Mongo then, and we had a customer send a query that should have been sort of killed off by our rate limiting, and wasn't for particular reasons, and it was basically freezing app servers, and then our load balancer was configured to say like, well, if we haven't gotten a response from the app server, either like this was good or this was bad, that app server is probably dead. Try another one, and we ended up just killing all of the app servers and taking everything down. And it took a bit to figure out what was going on, and why restarting things wasn't cleaning things up. And then when we figured it out, we rolled out changes to both the app server and the load balancer, and that calmed things down. Mm-hmm. But yeah, it's never fun. It's one of those firefighting situations where you get the whole engineering team on board, and you go through the process that you set up to handle these kinds of situations. You just do the work. It
seems like you had a more recent failure, maybe late last year or something like that.
Yeah, so our last major outage was in February of this year, 2015.
Okay. What happened there? Can you talk to us about it?
Yeah, so that was a failure in our Kafka tier. Okay. And so what happened there was we had to... Well, first of all, this one was actually better than the one in 2013 in the sense that not everything was down, right? Queries were working, and that was fine. But because Kafka was down, we were rejecting new events, which is obviously a very, very bad thing for us.
Hmm.
Um, and, you know, um, the reality is there the outage was caused by a maintenance event that should have been routine and wasn't. Just a strange thing in sort of Kafka's monitor or maintenance tool. Basically, like click the, essentially use the wrong option, and it um, started behaving in some pretty
Hmm.
nasty ways, which eventually made us essentially have to shut the system down, give it, like reconfigure it in some critical ways, and then bring it back up. And once we did that, everything went back to normal. But it was not a pleasant, not a pleasant thing for certainly our customers, who were the most important thing there, and not fun for the engineers who had to work through it.
How do you prevent these sorts of situations in the future? Is it by building better monitoring tools that track more things? Is that what
Yeah,
else?
I mean, it's building certainly monitoring tools to try and detect things earlier, see if you can intervene before they become user impacting, um, and it's building additional processes around engineering and deployment. Um, so now that we know that certain thing causes a certain kind of downtime, we don't allow that thing to happen anymore.
Right.
Um, so it's just building up your run book of things that you're allowed to do and things that you're not supposed to do.
Hmm. Would you say your experience at Salesforce working on scalability and performance has that helped you quite a bit in these sorts of situations?
Yeah, certainly. It's helped me. It's helped me a lot mainly in the sort of design and code and sort of algorithms phase. Um, at Salesforce, ops and engineering are pretty well split. So
I
much of
see.
the I wasn't doing much of the sort of live infrastructure work, but um, but yeah, Salesforce definitely helped from the perspective of
Hmm.
like, how do you build efficient, optimized code.
Hmm. There was another interesting article that I read on your blog that talked about noisy neighbors in this sort of app where if you have someone that's running a very maybe complicated or time intensive query, how do you protect your other customers from that sort of noise?
Yeah, it's a tricky one, right? It's every multi-tenant SaaS provider has this problem potentially, from AWS all the way down to, small SaaS folks. Um, and really, it all comes down to metering and rate limiting. Um, so we make our best attempts at determining sort of what your fair slice of Keen is, and um, try to try to make it so that you can't use more than your fair slice. Now, it's a little tricky because we've got we've got some pretty beefy systems, and we want them to be used. So the calculus is, we don't want people to sort of use more than their fair share. But if the systems have capacity in a moment in time, we'd love to be able to
Mm-hmm.
use them, um, for you, even if it's technically not fair, because we want to give you the best experience you can have. And so that's a tricky one, and we're constantly battling that and trying to figure out where the right, like what are the right algorithms, what are the right things to be paying attention to, what are the right signals, um, and so yeah. But at the end of the day, it's all
Mm-hmm.
metering and rate limiting.
How do you set something up like rate limiting?
So rate limiting is one of those things that actually hasn't, from my perspective, hasn't been solved in a generalized way. There's no like, this is the Rails gem or Ruby gem you use if you're building rate limiting in Rails, right? There's some ideas out there, but um, that one feels like there's some opportunity around like how do you actually build rate limiting in a meaningful way. I know AWS is starting to get down that route with something like their API gateway feature, but so the long story short, it's something you have to roll yourself, right? So the first version of it that I built was based off of Mongo and using like atomic counters, um, and it's sort of evolved from there.
Mm-hmm.
So we do it in multiple places, and The other tricky thing is we have a service-oriented architecture that I haven't talked a ton about, but they're like, we have the service that handles our queries, and that does its own rate limiting separate from the event rate limiting that happens in the Python server. So there's multiple instances of these things happening.
Gotcha. I also wanted to ask you, I forgot to ask you this about SoftLayer versus AWS. You started Keen back 4 years ago. How long does that make sense, or when does that make sense? When should you use something like SoftLayer versus AWS or any other cloud provider?
Yeah, so when we started the company, there were two main reasons we chose SoftLayer. One was IOPS, so we needed to have our database provisioned in a way that would give us a lot of IOPS. And back then, that was before any of the SSD instances in AWS, and that was before even provisioned IOPS. So, or actually, I think what's correct to say is back before provisioned IOPS worked the way that we just wanted it to. I don't. I'd heard a lot of things about how it wasn't quite where it needed to be yet. And network. So we knew from the beginning that we wanted to be across multiple data centers for data security and redundancy. And SoftLayer gives you network transport between their data centers and the private network for free. So that was a really big advantage over AWS, which even between AZs in the same region charged. So those are the two big ones, network and IOPS. And these days, I think AWS is largely caught up. There's some questions about data transfer between AZs or between regions, but the price of them. But if I were to start the company again today, probably would start with AWS.
Mm-hmm. Interesting. At the beginning of the interview, you mentioned how you can have different kinds of devices use your API, whether it's a mobile phone or some kind of wearable.
Mm-hmm.
I really think we're moving towards an era where we have all kinds of different wearables like Google Glass, all these different things that you can wear. How is that going to change analytics? Do you see that changing it at all, or is it going to be more of the same? What do you think?
Yeah, it's definitely going to change things. The first and probably most important or most impactful thing is just scale.
Yeah.
Right? So there's going to be so many more things connected, just generating so much more data. So having tools to deal with that kind of scale is going to be really, really important. Yeah. Outside of that, I mean, you're going to be able to do new kinds of analysis, right? So if we're starting to have data on really like what people are doing, because that's what wearables kind of enable, is really granular detail about what somebody's looking at or what's going on with their body through something like an Apple Watch. Like that is it opens the doors to some pretty scary things.
Yeah.
Be careful with that.
Yeah.
We try to be really aware of that in our TOS and make sure people aren't sending us nasty, nefarious things.
Mm-hmm.
But you can start doing some really interesting things and really interesting analyses of like how populations are moving around and what populations are paying attention to.
Mm-hmm. When you look at some of these technologies like Oculus Rift, I mean, it's mind-blowing when you see some of the demos where people put the headset on and they're in a different world, and then they take it off and they're stunned for a few seconds because they're like, that was too real, And it's when you're moving towards something like that and wearables, I mean, what about if they're inside your head one day and you can just collect all kinds of crazy information about your brain, your body? It's slightly terrifying, I'm not going to lie.
It is, yeah.
But we'll see how that turns out.
Yeah. It's going to be, the next 10, 15 years are going to be pretty interesting.
If not from just a moral standpoint, but also from security.
Absolutely.
Being able to hack your body, anyway.
Well, it's one of the, the security perspective is a really interesting one. It's why we can't be using... It's really why we can't be using any of our body, like pieces of body, whether it's fingerprints or something else, as security credentials, because those are the things you can't change, right? It's not like you can change your retina, you can't change your fingerprint, really. You can burn it off, I guess. But Um, so we have to be really smart about that.
That's a great point. All right, I want to wrap this episode up with one more question. I
Sure.
was really thrilled to read about this when you ended up going to DC to offer your perspective on net neutrality. Can
Yeah.
you tell us what that was like and what you got out of it?
Yeah, sure. I mean, it was one of those random things. We were working, we're based in San Francisco. Excuse me. We're based in San Francisco, and um, just the building we were working out of a shared office space. The group that sent me out happened to be there, so they were looking for startups that um, had opinions about net neutrality back when the FCC was still thinking about it. I mean, they're still thinking about it today, but when they were thinking about it really actively and hadn't yet released their rules. Um, and yeah, I mean, it was a really interesting experience. I flew out to DC for a day or two, met up with a bunch of lawyers and a bunch of other startups who were passionate about net neutrality. And it was a fascinating thing. We went to the FCC, we went to Congress, talked to a bunch of different folks, and yeah, it was fascinating to sort of see how the sausage was made, see sort of what political insiders were saying were like the main issues. It was cool to see that most people understood the core issues and understood that um, the perspective the FCC eventually took, which is the perspective that I was speaking to, and the perspective that all the startups were with speaking to. A lot of people understood. A lot of people wanted to get it done. They needed help from a sort of political standpoint of getting it done, because there's a lot of really powerful interests out there fighting against it, and a lot of money against it. So it was yeah, I mean, it was awesome. We had a great time, and clearly somewhat effective because the FCC ruled in our way.
Awesome. Well, thanks a lot for doing that, and thank
Sure.
you so much for doing this interview and sharing, some of the problems that you've ran into. Hopefully, somebody listening to this is going to not run into these issues thanks to you doing this. So, thanks a lot for sharing that, being open about it, and also sharing about your product and how it works. A lot of people tune in the show and are really interested in learning how these product works, myself included, or I wouldn't
Cool.
be doing this. So,
Yeah.
thank you so much, and thanks for making an awesome product too. Thank you, Dan. I
Cool.
appreciate it.
Yeah.
If people want to reach out, how do you recommend they do that?
You can hit me up. I'm just Dan at Keen.io over email. You can hit me on Twitter. I'm at DKador. So
Awesome. Thanks a lot. Thanks, guys, for tuning in. Please leave a comment to thank Dan for being on the show, and I hope everybody has a great day.
cool.
Take
Thanks,
care.
guys. Bye.